شكرا على جلب انتباهي للموضوع. Okay. What we were doing, we were using, okay, Routh-Hurwitz to test if a system is stable or unstable. To summarize what we have done so far, the first thing we'll do, we look into the characteristic equation.
Okay.
In the characteristic equation, if there is one term is missing or there is a sign change, we can conclude immediately that the system is unstable, and we stop. We will answer that if the question is the system stable or unstable, we will stop. We'll say, okay, the system is unstable. But if all the coefficient there and there is no sign change, then we will make the Routh matrix, and we do the calculation, and we look into the first column. If all the elements of the first column, there is no sign change in them, the system is stable.
No zero.
Okay, but as we move, we have special cases. The first case we said, all the, elements in here are non-zero. But during the process, if let's say this is 0, we cannot proceed. So we change this one into, what did we say?
Epsilon.
Epsilon, great. And then we proceed. This is one special case. The other special case is that this row, the entire row is 0. In that case, again, we cannot proceed. However, the way it's being treated is to look into the row before it, and we form what we call the auxiliary equation. The auxiliary equation usually, okay, always, not usually, it's always an even polynomial. Okay, so from here, I can write the auxiliary equation, and then I differentiate the elements of the auxiliary equation, and then I proceed. If you have auxiliary equation, most likely you will have either 2 poles in here or one here, one here. Most of the time you will have the pole on the j omega axis. So if you have poles on the j omega axis, what type of system you have in terms of stability? What do we call it?
Edge under.
إذا إيش السؤال؟
كيف؟
إذا إيش السؤال مرة ثانية معلش؟
السؤال, if I have 2 poles of the equation on the j omega axis,
undammed.
it means that I will have oscillation.
ايوه oscillations طبعا لانه ما في عندك الدامبنج ريشيو 0 الزيتا 0.
Okay. طيب. What do we call this type of stability? We call it marginally stable system. System is marginally stable because remember the definition of the input-output stability, okay, bounded input, bounded output. With the pure operation, the output is bounded. So we call this type, which is between the stable and unstable system, this is the borderline. We said our system is marginally stable. Now, this is we already covered. What we are going to cover in here, you have a system of higher order, let's say 5th, 7th, 9th, whatever, 8th, whatever. You will have here row of zeros. When you replace it and continue, somewhere in here, you will have another row of zeros. So you do the same thing which we have done. Get the auxiliary equation before it and then proceed. Okay? But in this case, if we do it, you might end up with all the elements after replacement will be positive, no sign change. So you think it will be stable. However, the reality is that if I have double pole in here on the j omega axis, the impulse response is going to be unstable and the system become unstable.
يعني يا دكتور الحين لو تعيد بس كذا بشكل مختصر ايش الفكره؟
كيف؟
I lost you في
So basically, in this case, if I have this case, let's say, okay, suppose I have it happen in here in the S4, let's say, and I think, okay, let's work it on the example. But in here, if I have, let's suppose I have two poles, suppose I have 1 over S square plus 1, the whole thing square. What will be the impulse response? What will be G of T? What will be G of T? What's the
هذه فيها كوساين الظاهر في التيبل.
اعتقد اذا كان 1 will be sine.
ممكن ساين صحيح.
Sine, and there will be also because of this, because of the repeated root, you will have the T with it.
مظبوط out. Yeah.
So it will, the system become unstable, even though from the first column it look like stable. And let's take an example. Any question here before we proceed to the example?
Yes دكتور. طب هنا هتكون باوندد ولا ما هي باوندد هنا؟ ما هي باوندد صح؟ هذه ما هي باوندد صح؟ will not be bounded.
It will, yeah, it will, if you have this situation, the system become unstable because of the T. Okay, suppose I have, this is what I have. This is the system which I have. This is the characteristic equation of the system. So let me form the first two rows. What are the coefficients of the first two rows? What will be in here?
So we start
1,
1,
2, 1, and 0. And the next to it?
1
again 1 2 1 0. السلام. واضح ان في صفر بعدها.
Okay. So let's put here 0 and 0. Let me proceed to this one, to the S3.
0 0.
It will be 0 0 0. So I have, I did not, because I should, okay, I should stop at, because this is going to S square, S to the 1, S to the 0.
Auxiliary equation.
So I should proceed. Okay?
دكتور
Yes.
معلش بس how did you get S5?
How do you get S5? S5 from the
Yes.
pure characteristic equation. This is the characteristic equation. This is given to you.
Which coefficients did you take?
If,
From where did you get the values? The coefficients or?
yeah, the coefficient. I put in here the coefficient. Okay, the coefficient of S to the 5 is 1. The coefficient of the S cube is 2. The coefficient of S equal to 1. This is the first row. The second,
Oh yeah.
the one which I, skip. So I'll have 1 with the S4, 2 with the S square, and 1 with the S.
Yes, الحين clear. شكرا دكتور.
Okay. So now, okay, this is what we said. Because of the 0 in here, I have 0. Definitely this will be 0. I have to do the, okay, the auxiliary equation. So what will be the auxiliary equation here? What is the auxiliary equation is going to be?
Remind us دكتور.
If
Remind us.
the auxiliary equation, we said, I will go to the line before the 0, to the row before the 0, and I will write the polynomial. So tell me, what will be the polynomial?
S4 S to the power 4 plus 2 colon
Exactly, S to the power 4 plus 2S square plus 1 equal to 0. Look, when you have the characteristic equation, you put 1, 2, and 1. So it's going to be s cubed, okay, sorry, s to the fifth, s cubed, okay, and s to the 1. Okay, now you alternate. So this is basically the polynomial which you have. And we said, then I will differentiate. Okay, this is the auxiliary equation. You differentiate the auxiliary equation. If you differentiate, this is what you'll get. Take the coefficient and put them here. So now I have a row which is not 0. The coefficient will be 4 and 4. Can I proceed?
proceed
Proceed in the same way.
yes. So minus 1 over 4.
It will be 1, 1, and then 0, 0.
صحيح.
So this is, I have problem. I have to do the auxiliary equation for it and then substitute the derivative of that one. Okay, so now
بس معليش يا دكتور ال1 هذا في الاس سكوير كيف مش المفترض ان احنا minus 1 over 4 4 minus 8
كيف which one? This one?
اي احنا ناخذ minus 1 over 4 صح؟ بس
مظبوط.
ناخذها بالابسولوت فاليو
Okay.
ولا
دقيقة. Let's see. Inshallah, I don't have any minus 1 over 4. Okay. And what do we have?
yeah and then we have 1
1, 2, 4, 4.
4
Okay. 1, 4 minus 8.
4 minus 8 مظبوط.
Okay. Which is equal to?
هذه ما هي absolute value دكتور صح؟ يعني determinant هذه المشكلة.
لا لو absolute value ما خلي النيجاتيف هنا.
صح.
Determinant. Okay, put it in this way. No confusion. So it's going to be 1 over 4 times minus 4, which is equal to 1.
نفس الكلام اللي بعده. تمام.
طيب. Now, according to our test, 1, 1, 4, 1, 2, and 1. The system should be stable.
Yes.
But this is not true. Let's look into the auxiliary equation here. This is the auxiliary equation, which we said the auxiliary equation is part of the characteristic equation. It's
صحيح.
if I divide the characteristic equation by the auxiliary equation, okay, I will have the fifth, I will have the rest of the pole of the system. I mean, the characteristic equation, it will divide the auxiliary equation. So basically, this equation will give me the location of 4 poles. And if I divide the characteristic equation by this one, I will get the 5th one. Okay, now, as I said, this is the characteristic equation. So the characteristic equation, the auxiliary equation, I can rewrite it as s squared plus 1 squared equal to 0.
صحيح.
Do you agree?
Yes.
So what are the location of the poles of the system?
Oh, this is in the
Minus
imaginary
1.
axis.
Okay, so s equal to plus or minus j, and plus or minus j again.
صحيح.
Okay, which means that I will have double pole in here and double pole in here.
Unstable.
This is where it will, because the pole on the j omega axis are not simple, my system become unstable.
Because ايش يا دكتور؟ انه
Because of the repeated pole on the j omega axis, the system become unstable.
so if we have repeated poles.
Look, this is where the term we have said, remember, this term, the T will come. for the repeated. If it is simple, it means only one pole, only j omega x, you will have only the sine or the cosine.
which is undamped, which is marginally stable.
Exactly. Any questions about it? Any questions?
جميل. طيب يا دكتور، لو مثلا الاكسيلري هذه ما طلعت معي في اول مره ورحنا للاكسيلري، مثلا جبنا الاكسيلري الثانيه اللي هي اس سكوير بلس 1.
اها.
from s square plus 1 معناها it is stable.
Yes, if you have the situation.
But always we take the first auxiliary.
Usually, look, usually إذا كان يعني عندك auxiliary equation حتطلع بالhigher order for the repeated pole. إذا ما طلعت بالhigher order, it means yeah, your system is stable.
جميل.
What you are saying, look, إذا الauxiliary equation طلعت هنا, it means that ما عندك يعني it will be the same case الأولى. زي ما أخذنا ما في repeated pole.
ممتاز. Simple pole.
Okay, so in here what we are saying, what you are going to get, you are going to 2 rows where you will have zeros with them. Okay,
جميل.
and this is basically what we have.
يعني دكتور إذا كانت 4 وفوق 4 6 8 هذه اللي هيكون فيها مشاكل.
Yes, yes. Whenever, yeah, you have the possibility for such cases, it will be at higher order system. يعني third order ما راح يصير عندك ما عندك it cannot be عندك هو 3 poles مثلا third order هو عندك 3 poles ما معقول يكون 4 منهم repeated ما
صح. وأنت كمان ذكرت نقطة مهمة إنه الأكسيلري always is an even function.
Yes, yes, it is. We are going, by the way, Shabab, we will be using the auxiliary equation in the next topic, root locus. It's very important. Okay. And the auxiliary equation, as I said, it is part of the, okay, in this case, okay, part of this equation. Remember, the auxiliary equation was s squared plus 2s plus 1, and this is s to the 5 plus s to the 4 plus 2s cubed plus 2s plus 1. Divide in here. What do you get? If you divide.
هذه s to the power 2 ولا s to the power 4?
S to the power 2 وهنا s to the power 5.
So s to the power 3.
Sorry, s to the power 4, you are right. And this is 2s squared.
s يعني.
S, exactly. S in here. S multiplied by this one, what do we get?
S5 and then 2s3.
S to the 5, okay. Plus what? 2
S3.
S to 3 plus
S.
plus S.
Then subtract.
Plus S. So this will go, and what do you get?
Get S4.
S4 plus
2s minus 2s cubed.
so 2s s
minus 2s cubed.
minus sorry s this will go no the s cube no will go.
ما في s cubed. Oh هذه s cubed هذه فوق
This
هذه
is
s
S cube,
cubed.
yes, this is s cube, and this is 2s plus s. هنا s plus 1, the characteristic equation. So the s cube will go
2s squared دكتور.
here.
2s squared.
It's going to be 2s, sorry, 2s squared plus 2s squared plus 1.
طلعت نفسها يعني.
Which is basically, it is the same, so plus 1. So the fifth pole of the system is going to be s plus 1. So I will have, look, I will have double pole in here and 1 pole at minus 1. And let's see, I think it's given in here. Let's see. We did not use MATLAB, I don't know. Apparently, I thought I will have it. But anyway, so basically,
So the idea is clear, doctor.
كيف؟
The idea is clear now.
No, many times you will be asked the location of the poles. So from the auxiliary, you'll get, let's say 2 or 4 or 6 or 8 or whatever.
Then you divide the main.
And the rest will be, you know, you can get.
Yes, sir.
Okay, let's move into another topic. Okay.
دكتور سؤال على السريع بالنسبة للراوث هيرويتز criterion, is it the best يعني criterion in terms of the efficiency and in terms of يعني ولا في criterion أفضل وأفضل يعني وأقوى؟
You will, okay, look, you will have alternative. Now what we are going to, inshallah, I hope we will have time, we'll go to the root locus is very powerful. Nyquist is another powerful. So each one, look, it has, you know, advantage and, you know, in the design, usually, we will, you know, we'll go with the either root locus or the body plots. So it depends on what you want to do. Okay, let me, okay. I don't think okay, let me go. If you bear with me 1 second, currently I okay. Share. No, not this one. Stop share. Oh my God. Still not this one. Somehow I'm opening the same, stop sharing. I don't know why I'm, let me, okay, this one. Do you see the slide? Do you see the slide?
لا دكتور, we cannot see.
Okay.
Not yet.
Share.
Sometimes دكتور maybe خلاص اشتغل الحين.
Better, okay, you know what, let me reduce the number of files which I have in here. Let me close this one. Yes. Now do you see it?
Yes.
Yes.
Okay. Okay. So far, what we have done in the course, we talked about the absolute stability. What's absolute stability? Absolute stability is that the system is either stable or unstable. Okay? Black and white, stable or unstable. What we want to do, we would like to talk about another concept called relative stability. Okay? So the relative stability, okay, we are going to discuss in terms of the Routh-Hurwitz, and later on when we go to, you know, body plot and Nyquist. simply in here, if I have, let's say, okay, suppose I have this system. Okay. Which one do you think the poles of the system? The system, you know, all the cases are stable because the poles are in the left half plane. But which one will have more oscillation?
Which is nearer from the imaginary axis.
Exactly.
R1 and R1.
As you move to the j omega axis, the degree of stability will be less. So in the Routh-Hurwitz, we will try to figure out how far the poles from the j omega axis. The further, the more stable. The less will be the relative stability is, you know, I mean, is very little.
Yes.
If we go, yes.
هل هو صعب ان نخلي البولز ابعد من الجي اوميجا اكسس؟
كيف؟
يعني يعتبر اغلى؟ يعني يعتبر اغلى او
يكون افضل ولكن ايضا look, it is not always, you cannot, you know, you cannot always go well, it means, okay, you will have the problem maybe with energy. Okay, but look, simply what we are saying in here, if I have, okay, a pole which is, you know, near the j omega axis, I may run into stability problem.
بس دكتور قصدي how far do you want it to be يعني realistically?
Well, it depends on the question. For example, let me give you this example. Suppose I have this example. Okay. Now, I have a unit feedback system, and this is the G. Okay, that's basically I have. Okay. Sorry. This is, let's say, this is R, and this is Y. Okay, the system is third order of type 1. And suppose I need to satisfy a condition on the error. The error is function of K. If I change K, I will be able to, you know, satisfy this requirement. Okay, that's basically find K, which will, you know, okay, find K, which will, you know, to achieve this one, this is the steady state error. If you solve it, you will get K equal, must be greater than 100 to get this error. So let's say you will have, okay, suppose you would like to test the stability of the system now. Can we do it by Routh-Hurwitz? Okay. If you do the test, if you write 1 plus G of S equal to 0, you will find out if K greater than 81, the system becomes unstable. So it means that, you know, I cannot, you know, increase the gain unboundedly. So the relative stability in the, you know, if we use the gain, it means that how much gain I can add to my system before it becomes unstable. This will be more, you know, powerful method of testing. And that way we will be discussing it later on in the course, in the gain margin and phase margin. I just want to tell you what the relative stability means. So in the sense of, if we want to do the test in Routh-Hurwitz, we will be seeing how far we are from the j omega axis. While in the, while the body plot and Nyquist, we will have exact procedure to determine how much I can add to my system in terms of the gain before it becomes unstable. So the relative has
دكتور
an application.
دكتور الانبوت هنا هو اليونت فيدباك ولا اليونت ستيب عفوا فانكشن؟
الانبوت هنا ار
جنرال يعني ما حدد.
نو حدد رام.
رامب تمام يونت رامب اي
يونت رام حدد.
عشان كذا اخذنا الستيدي ايرور 1 اوفر اس في جي بي.
بالضبط. I don't, this is, I brought this example because I don't want to go over it. I just want to draw your attention. What does it mean to have relative stability? And how can I measure it? As I said, the relative stability, you can think about it, how much gain I can put in the system before it becomes unstable. You will see if you do it by, Routh-Hurwitz, the maximum you can go in the game will be 81. After the 81, the system becomes unstable. Okay? So, in the Routh-Hurwitz, as I said, the Routh-Hurwitz criterion, we will do axis shifting. While in the, if you go to the body and Nyquist, then in there, we will be talking about gain margin and phase margins, which are, totally different idea. But now for the phase shifting, or the axis shifting, this is, as I said, basically, I want to test. So I will do, let me shift this axis in the side. If I want to do that, suppose I have, determine the relative stability of the following characteristic equation. This is my characteristic equation. And I would like to see how much I can shift my j omega axis, in here before the system becomes unstable. So the method is trial and error. So let me assume, at first step, let me assume I will be doing the shifting by 2 units to this side. So Sn equal to the original S plus 2. Or S equal to Sn minus 2. And let's substitute this one in the characteristic equation. So the new characteristic equation, this is what I'm going to have. This is the new characteristic equation. Tell me, is the characteristic equation now stable or unstable? Is the system stable or unstable by this shift?
unstable.
Because there is sign change. So
طبعا لازم نسوي الراوث-هورwitz كرايتيريا صح؟ ولا خلاص لانه على طول هنا يا دكتور.
كيف؟
هنا على طول we can say it's unstable, right? Because we have a sign change
because of the minus sign. Now let's reduce. Let's go to make S plus 1. I will shift not 2 units, I will shift 1 unit. And substitute. This is your characteristic equation. The new characteristic equation. Do the Routh-Hurwitz test for this new one. And this is what you will get. There will be, because of the zero, it means that I have auxiliary equation of this one, which means that I'm going to have, so basically the system is going to be stable or marginally stable, which means that I can move by 1 unit and still my system is stable. So the relative stability in here, 1, you can think about it. But this method, as I said, this method, it is by trial and error. While if we go to the other one, in terms of the gain margin and phase margin, no. You can precisely calculate the gain which you can add to the system before it becomes unstable. Any question before we stop? Any question?
دكتور
تفضل.
how did we know that we يعني ان تحركنا بس قلت واحد بس الفرق بين الستيبل
اوكي من تحركنا لما تحركنا 2 يونت النيو كاركترستيك هذه اللي طلعت عندنا. definitely a system become unstable. So I cannot, if I move 2 units, the system become unstable. So let me try different. Let me try 1. By trying 1, this is the new characteristic equation. Do the Routh-Hurwitz. This is what I'm saying. Do the Routh-Hurwitz. And this is the Routh-Hurwitz test for you. Clearly, the system either stable or marginal stable at least.
طيب دكتور
Yes.
لازم يتحرك مثلا 1 2 ولا ممكن يتحرك 0.5 0. لو استدعى
No,
الامر
you can. And here, as an example, no, you can definitely. You can go.
يتحرك as small as we can.
Yeah. Suppose at 1 become also unstable. So you go to the 0.5.
جميل. وايش يا
Okay.
دكتور فكره الفيز مارجن والهذه؟ ايش فكره انه الفيز مارجن is يعني
Well, we'll come to it. Think about it. The gain margin. It is how much gain I can add to the system before it become unstable.
before it become unstable. I see.
And this is okay. For example, in the example which I said in here. Okay. So basically, what we are saying, the marginal stability is going to be, or I mean, the gain margins will be the 81 or 20 log 81 in dB. Okay. I cannot go beyond the 81. If I go beyond the 81, my system become unstable. We will come to it. Don't worry about it. I just want to mention that the relative stability, we will come to it a little bit later. In here, by shifting the axes.
طيب دكتور ايش فد الحين relative stability؟ يعني احنا we know now and we can مثلا move or there is if we move the imaginary axis, let's say by 1 unit, still our system is stable. If you move it further, maybe the system will be unstable. So what this will be يعني how can we reflect this on our design؟ يعني ممكن نستخدم Routh-Hurwitz criteria مرة واحدة وانتهى يعني. What is the advantage, let's say?
يعني look, honestly,
another tool بس.
Honestly speaking, if you want to do the relative stability, you will use the other method. يعني if you want to do the design, that method it will tell you precisely. But no, يعني it will give you, okay, it will, يعني we can give you the procedure which will, you can figure out how much gain I can add to my system before it becomes unstable. In here, it is basically you add and then you try to check. Okay. You can add more, but you have to check. Okay. For example, in here, suppose you add the 100 and you figure out now, okay, if you check the stability by Routh-Hurwitz, it becomes, so you have to reduce. And in a way, yani, this method, honestly speaking, I don't know. It's not that powerful. It's just indicator, okay? If you want real design, you go to the phase margin, gain margin. This is indicator.
هل في دكتور في الماتلاب في فانكشن للراوث-هورwitz كرايتيريان ولا اصلا الماتلاب اصلا يعطينا البولز على طول وخلاص؟
Definitely يعطيك البول. But well, I'm not sure if the Routh-Hurwitz إذا الماتلاب يعطيك التابيليشن قصدك.
ايوه قصدي التابيليشن.
لكن الماتلاب definitely الماتلاب maybe I'm not sure. I know we are going to go the next lecture root locus, which is basically, by the way, شباب اللي يبغى the class is over. If anybody would like to leave, it is totally